y values. So we know that what we're looking for is which of these functions is which. We know one is the original function, which we call w. One is its first derivative, w prime, and one is its second derivative, w double prime. And how do we determine which one is which? Well, let's review how they're related to each other. For some graph w prime will have positive y values. So let's actually write it that way. W prime will have positive y values. So it'll be above the x-axis when w has a positive slope, because w prime gives us the slope of w. Similarly, if w prime is below the y-axis, then w will have a negative slope. And w double prime will have positive y values when w is concave up. So looks like this, right? And similarly, w prime will have positive y values when we'll have negative y values when w is concave down. And remember also that w prime and w double prime are related. W prime's derivative is w double prime. So w double prime will have positive y values when w prime has a positive slope. Where by slope here I mean slope with the tangent line. Okay, so how do we determine which is which? Well, we just pick one and we see if it makes sense for it to be w. So, I don't know, let's pick h. Does h equal w? Well, h is decreasing for this part of the graph. So if h was w, then one of the other graphs would have to have negative y values for all of the x values that we just highlighted. So we highlighted these x values on the h function as decreasing. So essentially these values on the x-axis. So do either f or g have negative y values for all of these, like, essentially for everything from negative infinity to a little past -1? No, f certainly doesn't, because f is positive y values here. And g doesn't, because g has positive y values here. So neither one of these functions can be the derivative of h. So not only do we know that h is not w, we know that h has to be w double prime, because that's the only function whose derivative is not represented on this graph. So now we know h is w double prime, and we want to know which one is w prime and which one is w. So let's compare f and g. If we look at f, maybe, f is decreasing through all of this part. So if f was w and g was its derivative, then we would need g to have negative y values for those in that same region of the graph, this part of the x-axis, and that seems to be the case. So let's keep checking this. My hypothesis here is that f is w and g is w prime. So if I go back to f, then the next region of the graph from here to here. That's, I guess I'm highlighting G now. So G is positive, has positive y values from here to here. So if we're right, that G is the derivative of f, then f should be increasing for that same part of the graph, those same x values, and that seems to be true. And then the next section, f is decreasing right here for these x values, and G is this one. G is negative here. And then finally, f is increasing here for these x values and y, and G is positive. So it does seem to be the case that G looks like it's the derivative of f. And now let's check our work by checking to see if it makes sense that h is the second derivative of f. So remember, we're looking for concavity. So f is concave up here till somewhere around here. And f is also concave up in this region. So if we look at h, we would be expecting that h has positive y values for this part, these x values here that I just highlighted. And if we look at h on those x values, it does have positive y values. Similarly, f is concave down here in this middle section, which corresponds to these x values. And we would expect then h to be negative, and it has negative y values for those x values in question. So yes, it makes sense that h is the second derivative of f, and it made sense that g was the first derivative of f. There's one more thing we could check, just to be absolutely sure that we haven't messed things up. We're probably good at this point. But let's just check one more thing. Let's check and make sure it makes sense that the derivative of g is h. Because if g is w prime, then w prime's derivative should be w double prime. So let's look at g. G is increasing on this part. So up to close to -1 there, not quite to -1 for these x values. And so we expect h to have positive y values on that same region, and it does. And then g is decreasing here in the middle for these y values. And we would expect h to be negative there because the y values of h give us the slope of g, and it does. And then finally, g is increasing on this part of the graph, and h has positive y values on that part of the graph. That's from, I don't know, it looks like about -1/4 to infinity. And so, great, it makes sense. It checks out, and so I think we've got the right answer here.